Hello, this is a review video for solving equations. So here are the learning targets that go with it. It says I can solve basic and multi-step equations, I can solve literal equations, and I can solve linear equations. So I hope you guys are watching this ahead of time. It's going to help you with your homework and in class because we're just doing a really quick 1 or 2 day review for solving equations before we move on. So a couple things just to think about or remember. I feel like the first part is obvious, but I always like to say it anyways. Read the directions carefully. What variable is the problem asking you to solve for? So it seems silly, but I've had multiple kids, they just get going fast on their homework or benchmark or test, and they just miss something that would have been helpful if they had seen it. Second thing, think about what operations are being done. So does the problem involve addition, subtraction, multiplication, or division? And then we have to remember that we use inverse or opposite operations to solve for the indicated variable. So we're just going to jump right into some examples. The first two here are multi-step equations. They both only have one variable, so the left one, like 2x minus 8 is equal to negative 12. Well, there's only one variable in there, it's x, so I must be solving for x. Some of you guys like to draw like a line down to help you keep everything balanced. If that helps you, go ahead. So if I'm trying to solve for x, remember we are working PEMDAS backwards. So I need to start with addition or subtraction, and that's going to be this negative 8 right here. Since it's negative, I need to add 8 to both sides. So then I'm left with 2x is equal to negative 4. And, oops, it's a little messy. Now, I just have the 2x on the left side. That's multiplication. So I have to do the opposite, which is division. And I can see x is equal to negative 2. Here's a slick thing with equations. There's always a way to check them. So let's say on the homework or your benchmark, you want to make sure you got it right the first time, which is understandable. So you can always plug it back in. So here I could take the answer I got and plug it in. So I get to do 2 times negative 2, because that's what I got for x. Subtract 8, and I'm going to check, does that equal negative 12? So that's supposed to be a question mark. So I get negative 4 minus 8, because I distribute that. It's equal to negative 12. I'm still checking to see if it's right. I get negative 12 is equal to negative 12. That's true. So that means my solution must be correct. Alright, let's look at our problem on the right. Negative 4y plus 3 is equal to negative 21. Again, there's only one variable, that y, so we must be solving for that. Again, we have some addition and subtraction to take care of. It's a positive 3 or it's being added, so I need to subtract it. So I have negative 4y is equal to negative 24. I'm left with the negative 4 multiplying with y. So to take it away, I need to divide. And I get y is equal to a positive 6 because my negatives cancel. Okay, so here again, still only one variable. So in the left equation, we're dealing with a as our variable. It's in 2 spots now though, and on the right, we are dealing with x. So let's start with the one on the left side, 7a minus 3 equals 3 plus 6a. It doesn't matter where you start here. In other words, like what you move first. So I'll just do kind of what I would probably do if I was solving this on my own, which I am. And if you were to do it a different way, you certainly can, and then check your answer with mine. So that minus 3, I want to take care of first. So I do the opposite, so let's add 3. So I'm left with 7a is now equal to 6 plus 6a. Now I need to get the a's together, so I have the 7a on the left and the 6a on the right. The 6a on the right is positive, so I'm going to subtract it. And I'm left with 1a is equal to 6. And then I divide out the 1. So here a is equal to 6. Looking on the right, we have a little bit more work here. I see those parentheses, so on the left side that negative 8 multiplied by negative 8x minus 6. That tells me I need to distribute that negative 8 through first. So negative 8 times negative 8x gives me 64x. Negative 8 times negative 6 gives me 48. And then I have is equal to negative 6x minus 22. Again, from here, feel free to start wherever you want. And I'm going to take care of that negative 6x. So I'm going to add it. So I get 70x plus 48 is equal to negative 22. So the x's are taken care of. I need to get those plain numbers together, so that positive 48 needs to be subtracted. So I get 70x is equal to negative 70, and then 70 and x are multiplying, so I need to divide 70 out. So here x is equal to negative 1. Even though this original equation up here is longer, I could plug negative 1 back in again and make sure I get the correct answer. Okay, so these are two literal equations, and all it means when I say literal equations is that there's more than one variable in the equation. So like the one on the left, there's an a and an m in there, so it's a literal equation. And I'm telling you that we should solve for a. So here, a is on the left side, but it's also being multiplied by 12 and m, so I need to get rid of that 12 and m. So I can actually divide them out together. So divide by 12m. 12's gone, m's gone. So I have a is equal to 4 divided by 12m. And then I need to simplify my fraction, so I can divide 4 and 12 by 4. So I get a is equal to 1 over 3m. Final answer. On the right side, we have x is equal to 2y minus z over 4. So we have three variables there. We have x, y, and z. And I'm saying let's solve for z. Z's up top, so I need to get rid of the 4 in the bottom. So we are dividing this whole piece up top, the 2y minus z, by 4. So I'm going to multiply 4 on both sides. That gets rid of the 4 here. And I'm left with 4x is equal to 2y minus z. And now I can go ahead and keep moving forward. So I'm going to subtract 2y because it's positive and I'm trying to get it away from the z. I keep it as 4x minus 2y. And if you think back to variables, the x and the y are different, so I can't combine them. So on the right side, I have a negative z. I'm going to think about what number would be there to help me with my next step. It's a 1. So I know I have to divide out that negative 1. And I get negative 4x plus 2y is equal to z. And that became a positive because I had negative 2 divided by negative 1. Alright, two more examples. So on the left I have 3x minus 2y is equal to 18. And it says solve for y. If you remember, that is actually a linear equation in standard form, which we'll see again in a few weeks. So I'm trying to solve for y. So let's see here. I definitely want to move the 3x. It's positive. So let's subtract it. So I'm left with negative 2y is equal to 18 minus 3x. Again, I can't combine the 18 and the 3x because they're not like terms. And then I have to divide out the negative 2. Some of you guys like to divide each piece like that by the number. That's okay too. So I get negative 9. It becomes plus 3 halves x because I have two negatives again. And that's my final answer there. The one on the right, there's only one variable again, just that x. So I'm trying to solve for that. For some of you guys, this one might seem a little silly, but I know sometimes fractions can throw us off. So I'm going to start with that 5 in the bottom of the fraction. That tells me I'm dividing that right side by 5. So to get rid of it, I have to multiply both sides by 5. So that cancels, and then I'm left with 15 is equal to 2x. And now I know to get rid of the 2, I need to divide it out. So I get x is equal to 15 halves, or if you like decimals, x is equal to 7.5. If you still have questions, please maybe come in for lunch or after school, find more videos, or get help somewhere else so you are feeling comfortable with this material. Thanks for watching!